Imagine a star. Not in space. Not millions of miles away. But here. On Earth. A sphere of fire. Hotter than the sun's core. Burning at impossible temperatures. Contained by human hands. This is not science fiction. This is not a movie prop. This is a real machine. Built to recreate the sun. Deep inside a laboratory in China. Engineers pushed matter beyond limits. Beyond steel. Beyond imagination. They heated hydrogen to 120 million degrees. 5 times hotter than our sun. And they held it there. For decades, fusion was a dream. Always 30 years away. Always just out of reach. Until now. Humanity has chased one goal. Unlimited clean energy. No smoke. No carbon. No limits. Our sun does it naturally. Every second. Converting hydrogen into pure light. Powering life itself. Fusion forces atoms together. Crushing them under extreme heat. Releasing unimaginable energy. If we master this process, energy becomes limitless. Civilization changes forever. The question is, can we control it? Fusion begins with hydrogen. The simplest element in existence. 1 proton. 1 electron. Yet it powers the universe. But not ordinary hydrogen. Scientists use special isotopes. Deuterium. Tritium. Heavier. More unstable. Deuterium can be extracted from seawater. Tritium can be bred from lithium. The fuel is abundant. Almost limitless. But abundance is not the problem. Temperature is. Fusion demands extremes. Over 100 million degrees. At that heat, matter cannot stay solid. It cannot stay liquid. It becomes plasma. A fourth state of matter. Plasma is unstable. Chaotic. Violent. It twists and writhes like a solar storm trapped in a cage. No material can touch it. Not steel. Not tungsten. Nothing survives direct contact. So scientists built invisible walls. Not from metal. But from magnetism. Superconducting magnets generate immense fields. Strong enough to bend charged particles. Strong enough to hold a star. This machine is called a tokamak. A donut-shaped chamber. Designed to trap a miniature sun inside. Inside the tokamak, plasma does not sit still. It spirals. It rotates. It fights containment. Every second is a battle. Charged particles follow magnetic lines. They cannot cross them easily. The field bends their paths. Like rails guiding a train. The stronger the magnetic field, the tighter the cage. The tighter the cage, the hotter the plasma can become. Strength means survival. But plasma is unstable by nature. Tiny fluctuations grow fast. A ripple becomes a wave. A wave becomes collapse. These instabilities have names. Kink modes. Edge-localized modes. Invisible threats inside a star. For decades, reactors shut down in seconds. Plasma collapsed. Energy was lost. The dream slipped away. Fusion is not just about heat. It is about balance. 3 variables must align perfectly. Temperature. Density. Time. This balance is called the Lawson criterion. A mathematical threshold. A gatekeeper to unlimited power. If temperature is high but time is short, fusion fails. If density is low, energy escapes. Perfection is required. For 70 years, humanity chased this equation. Always close. Never crossing the line. Until now. Then came East. Experimental. Precise. Relentless. China's artificial sun. Engineers redesigned the magnets. Stronger fields. Better stability. Tighter control. They improved cooling systems. Superconductors must stay near absolute zero. Even while containing a star. Inside the chamber, plasma ignited. It spiraled. It stabilized. It held. 10 seconds passed. Then 20. Then 50. No collapse. No shutdown. 100 seconds. Plasma still burning. The world took notice. 120 million degrees Celsius. 5 times hotter than the sun's core. Sustained. Controlled. For the first time, duration became the headline. Not just temperature. Not just theory. Time. Then they pushed further. Longer confinement. Higher performance. Greater confidence. Minutes instead of seconds. Stability instead of chaos. A line had been crossed. Then came the real milestone. 403 seconds. Plasma sustained. Stable. Controlled. Nearly 7 minutes. Not a spark. Not a flash. A continuous artificial star. This was not luck. It was precision engineering. Years of refinement. Thousands of adjustments. Every magnetic fluctuation was monitored. Every instability predicted. Algorithms guided the plasma in real time. Artificial intelligence became a silent partner, adjusting fields in milliseconds, preventing collapse before it began. Stability at this scale changes the equation. Literally. Time multiplied energy output. But sustained plasma is not the same as net energy. The reactor still consumed more power than it produced. Fusion's holy grail is ignition. When the reaction powers itself. No external heating required. East has not reached ignition. Not yet. But it moved closer than ever before. The breakthrough was not perfection. It was proof. Proof that long-duration fusion is possible. The world was watching. Scientists across continents took notice. Fusion was no longer theory. It was measurable progress. Because China is not alone in this race. Fusion has become a global mission. A scientific arms race without weapons. In southern France, another giant rises. A machine even larger. Even more ambitious. This is ITER. A collaboration of more than 30 nations. Designed to achieve net energy gain. ITER's goal is simple in theory. Produce more energy than it consumes. Sustain it. Prove it works. Private companies have joined the race. Billions of dollars are flowing into fusion startups. The pace is accelerating. Superconducting magnets are stronger than ever. Materials withstand greater stress. AI stabilizes plasma instantly. Fusion research has shifted. From physics experiment to engineering challenge. From dream to prototype. Energy defines power. Power defines geopolitics. Fusion could redraw the global map. A world powered by fusion would not depend on oil. Not on coal. Not on gas. It would depend on knowledge. Today, energy comes at a cost. Coal darkens skies. Oil fuels conflict. Gas warms the planet. The bill is environmental. Carbon dioxide traps heat. Oceans rise slowly. Storms grow stronger. Climate systems destabilize. Fusion produces no carbon emissions. No greenhouse gases. No air pollution. Only helium as byproduct. Unlike fission, fusion cannot melt down. If control fails, the reaction stops. Instantly. Naturally. There is no chain reaction runaway. No catastrophic explosion. The physics simply shuts it off. A stable fusion grid could power megacities. Desalinate oceans. Drive carbon capture at scale. Energy abundance changes economics. Cheap power lowers manufacturing costs. Innovation accelerates. But abundance disrupts markets. Fossil fuel industries shrink. Entire regions must adapt. Nations built on oil exports could face instability. Energy shifts reshape alliances. Power rebalances. Fusion is not just physics. It is policy. It is economics. It is the architecture of the future. But fusion is not finished. Not even close. The physics works. The engineering is brutal. The scale is enormous. The inner wall faces neutron bombardment. High-energy particles slam into steel. Over and over. Over time, materials weaken. They swell. They crack. Radiation reshapes their atomic structure. Engineers search for stronger alloys. Tungsten. Advanced composites. Self-healing materials. Tritium fuel presents another challenge. It is rare. Radioactive. Difficult to store safely. So reactors must breed their own tritium. From lithium blankets lining the chamber. Then comes heat extraction. Turning plasma energy into usable electricity. Without losing efficiency. Steam turbines still drive the grid. Fusion must integrate with existing infrastructure. It must be practical. And cost remains a barrier. These machines are enormous. Complex. Expensive. To power the world, fusion must scale. Smaller. Cheaper. Faster to build. The race continues. Fusion is no longer a distant dream. Private companies are building smaller, faster reactors. Ambition is global. Billions of dollars are being invested. Startups race to produce net energy first. Every second counts. The race is not just about energy. It is about influence, wealth, leadership in science. Some startups aim for compact reactors, small enough to fit in cities, power entire regions. Others focus on megaprojects, gigantic plants supplying millions of homes. Governments fund research. Private companies experiment. Collaboration and competition exist side by side. Commercial fusion is still years away. Estimates vary. Optimists say a decade. Cautious voices warn longer. But every experiment pushes knowledge forward. Every milestone reduces uncertainty. Every breakthrough inspires hope. If fusion reaches the grid, electricity costs could plummet. Entire economies could shift overnight. Fusion is not magic. It is effort. It is persistence. It is humanity mastering the power of stars. Imagine a world powered entirely by fusion. Energy is abundant, reliable, clean. Cities hum with new life. No smog. No acid rain. Oceans stabilize. Forests recover. Nature regains balance. Climate change could slow. Carbon capture becomes optional. Humanity finally buys time. Abundant energy transforms transportation. Electric planes. High-speed maglev trains. Hydrogen fleets. Industry no longer fears cost. Factories run 24/7. Innovation accelerates. Jobs evolve. Education adapts. AI tutors powered by unlimited energy. Schools flourish everywhere. Energy abundance could end inequality. Remote regions gain power. Entire nations thrive. But risks remain. Material fatigue. Economic disruption. Security challenges. Fusion is not risk-free. Humanity stands at a crossroads. The choice is ours. Innovation, responsibility, and foresight must align. The artificial sun shows us what is possible. Will we rise to the challenge? Will we master the stars? Humanity has glimpsed the power of stars. It is awe-inspiring, dangerous, and transformative. Fusion shows what we can achieve when physics and engineering meet. Precision, patience, perseverance. Yet the world must decide. Do we harness this power wisely? Or let ambition outrun caution? Ethical questions arise. Who controls the energy? Who benefits first? Who risks? Fusion is not just a technical feat, it is a test of humanity itself. Responsibility becomes energy. Imagine powering every home, hospital, and school without pollution, without scarcity, without compromise. Imagine transporting water to deserts, farming in barren lands, connecting humanity through energy. Fusion could rewrite history, not by weapons, not by conquest, by abundance. But it demands humility. Science alone is not enough. Vision, ethics, and foresight must guide us. The artificial sun burns steadily. It asks one question: will humanity rise to meet it? The artificial sun continues to shine. It is stable. It is powerful. And it is real. East has proven a concept. A sustained artificial star is no longer science fiction. ITER and global projects now chase the next milestone: net energy gain. A fusion-powered world is closer than ever. Fusion is no longer an experiment. It is ambition made tangible. Effort transformed into light. Humanity is learning to control the fire of the stars. One pulse at a time. One breakthrough at a time. Energy abundance could power innovation. Reduce scarcity. Heal the environment. Transform society. The challenges are immense. Materials, cost, integration. Fusion demands persistence, not shortcuts. But the rewards are profound. Clean energy. Stability. Progress. A new chapter for humanity. The artificial sun is a beacon. It shows what is possible. It challenges us to rise. The question remains: will humanity master this power wisely? Will we become stewards of the stars? The world watches as fusion edges closer to net energy. Every experiment matters. Every second counts. East proved long-duration plasma is possible. ITER aims to turn that into energy surplus. Private startups push boundaries. Smaller, cheaper reactors emerge. Speed and efficiency are their weapons. Fusion is reshaping ambition. It is no longer physics alone. It is economics, politics, and ethics. Energy abundance could democratize opportunity, power entire nations, transform lives. The environmental payoff is immense. Cleaner skies, stabilized oceans, regenerating forests. Yet humanity must proceed with care. The power of stars is not forgiving. Materials, cost, and security remain hurdles. Fusion rewards those who persist. Every breakthrough is a lesson. Every milestone reduces uncertainty. Every spark inspires hope. The artificial sun burns steadily. It asks one question: are we ready to rise? Imagine fusion powering every city on Earth. Energy scarcity becomes history. Innovation accelerates endlessly. Deserts bloom. Oceans provide fresh water. Humanity reclaims barren lands. Climate change slows. Carbon emissions drop drastically. Nature begins recovery. Industry thrives. Factories run efficiently. Automation and AI expand under abundant energy. Education transforms. AI-powered tutors everywhere. Knowledge flows freely. Transportation becomes seamless. Electric planes, maglev trains, and hydrogen fleets connect the world. Energy abundance reshapes politics. Alliances change. Power dynamics shift peacefully. Fusion also brings responsibility. Misuse or neglect could waste the gift of the stars. The artificial sun is both tool and teacher. It demands foresight, care, and collaboration. Humanity stands at the threshold. The stars are within reach. Will we step forward wisely? Fusion is more than energy. It is knowledge made tangible. A testament to human ingenuity. Every experiment, every pulse, teaches us patience and precision. Abundant energy could heal our environment. Restore ecosystems. Empower every nation. Innovation accelerates. Transportation, industry, medicine, and education benefit. But the artificial sun demands responsibility. Misuse could be catastrophic. Fusion rewards foresight, ethics, and global collaboration. It is power and wisdom combined. History will judge how we wield this energy. As conquerors? Or as stewards? Fusion is a mirror. It reflects our ambition, our courage, and our responsibility. The artificial sun continues to shine. It is patient. It waits for us to rise. The question remains, will humanity master the stars? Will we rise to meet the challenge? Humanity stands before a new dawn. Energy abundant. Challenges immense. Decisions critical. Fusion is both promise and test. Science shows the way. Ethics must guide it. Abundant energy could end scarcity. Enable innovation. Empower every individual. Education flourishes. AI tutors reach every home. Knowledge becomes universal. Transportation evolves. Electric planes soar. Maglev trains glide. Hydrogen fleets connect nations. Yet fusion demands care. Materials, security, and global cooperation remain crucial. Every pulse is a reminder. Power of the stars is not to be taken lightly. Fusion shows what we are capable of. Ambition. Innovation. Responsibility. The artificial sun waits patiently. It asks, are we ready to rise? The choice is ours. Will we master the stars? Will we build a future worthy of the gift? The artificial sun illuminates more than labs. It illuminates our potential. Every nation can harness this power. Every community can benefit. Collaboration is essential. Energy abundance reshapes society. No longer scarcity, but innovation drives progress. Clean skies. Thriving ecosystems. Cities harmonized with nature. Fusion is also a mirror. It reflects our responsibility, ethics, and foresight. Mistakes could be costly. Oversight, neglect, or greed could waste this gift. Yet hope persists. Every experiment, every breakthrough, brings us closer to mastery. The artificial sun is patient. It waits for humanity to rise to the challenge. The question remains, will we use this power wisely? Will we build a future worthy of the stars? The choice is ours. The stars await. Will humanity rise to meet its greatest challenge? Humanity stands on the brink. The artificial sun shows us what is possible. Abundant energy could end scarcity, fuel innovation, and restore our planet. Fusion is more than technology. It is a test of wisdom, ethics, and foresight. Mistakes could be catastrophic. Neglect could waste the gift of the stars. Yet hope persists. Each experiment, each breakthrough, brings us closer to mastery. The artificial sun is patient. It waits for humanity to rise to the challenge. This is a moment of opportunity. A chance to redefine what is possible. Will we rise to meet it? Will we master the stars responsibly? Fusion is both tool and teacher. It demands knowledge, care, and foresight. The final question remains, are we ready to rise? Are we worthy of the stars? Humanity now sees the potential. The artificial sun shines steadily. Fusion energy could transform every corner of our world. Education, industry, transportation, all can flourish under this new power. But fusion demands care. Ethical and responsible stewardship is crucial. Neglect or misuse could squander the gift of the stars. Each pulse teaches patience. Each breakthrough inspires hope. The artificial sun asks us to rise, to be wise, to be responsible. This is our moment. A chance to redefine what humanity can achieve. Fusion is both a challenge and a teacher. Will we listen? The final question remains, are we ready to rise? Will we master the stars responsibly? The artificial sun burns steadily. It is a beacon of human potential. It asks us to rise, to innovate, and to act responsibly. Fusion is both a gift and a challenge. It tests our wisdom and foresight. The world could be transformed. Energy abundant. Scarcity eliminated. Opportunity universal. The responsibility lies with us. Will humanity be worthy of this power? Every breakthrough, every experiment, teaches patience and perseverance. The artificial sun waits silently. It challenges us to rise and meet the future. Humanity stands at a threshold. Will we master the stars responsibly? This is the ultimate test of ambition, ethics, and courage. Will we rise? The stars await. The question is yours, are we ready? Comment below.